Hello and welcome back to another video, and in today's video we're going to be looking at while loops. Okay, so a while loop is another repetitive structure. Okay, you're going to keep doing this while something is going on. Okay, so for example, in this one we have k equals 1. Okay, it's a loop indicator, and we're going to say while k is less than 5. Okay, and inside the while loop, k equals k plus 1. So we're going to add 1 to it, and it's going to break out of this while loop. I type return when it basically is greater than 5. And let me show you. Greater than or equal to 5. So let me show you. Let me hit do this and put pause again. So if I run it, go to my command window. So I added 1, so k is 2. K is 3, that's still less than 5. K is 4, that's still less than 5. So the loop is going to go, and then boom, k equals 5. Is that less than 5? Nope. So it stops. Okay, so if you notice, it needed to calculate 1 more, because 4 is not less than, 4 is still less than 5, so it's going to add 1 more in this case, so k is 5, and then boom, it breaks out. So you want to make sure you're aware of that. Okay, so here's another example. So I just cleared my command window. Again, loop indicator. We have an initial value for a, so a of 1, so parenthesis 1. So a is going to be a matrix. We're going to build that matrix. And we're going to do this while a of k, which is 5 raised to the k, is less than 1,000. So here we have a loop increment value. So in a while loop, you have to add 1. So you have to create that loop indicator, where a for loop is already defined for that. All right, while loop doesn't. So k is k plus 1. This is our equation, 5 raised to the k, and we're going to keep doing it until this is less than 1,000. All right, and again, we're building a matrix. That's why it's parenthesis k. So a of 1, a of 2, a of 3, because k is we're adding 1. Okay, so let's do this. Let's delete that, put a semicolon, go down here and put pause so you can see this code. So let's run this, go back to the command window. So k, actually let me do this right here, perfect, so you can see both. All right, so again, k is 2 now, so it's 5 and 25. So we have 2 numbers for a. Now if I hit enter, k will be 3, and it should be what? 5 times 5 times 5. So 125. So we're going to have 3 numbers in a. All right, is still less than 1,000. Keep going. Okay, so k is 4, a is 625 now. That's still less than 1,000. We'll run it one more time. K is 5, and a now is 3125, so the loop will stop, because it's no longer less than 1,000. Okay, cool. All right, let's do something else. So let's clear all CLC. Okay, now what we're going to do is we're going to ask the user input, enter positive value, end. Okay, while, oh, my keyboard, awesome, thank you. While x less than or equal to 0, f print, we'll do this, f print f, x is not positive, input, and then we're going to please enter positive value, and then end. Okay. So we're having the user first, and we want them to put a positive value. If it's a positive value, the code stops. All right. And then boom, down here. We're going to keep doing it. So say it's a negative value. Okay. So it's going to, if it gives you a negative value, it's going to keep doing this. It's going to clear the command window. It's going to tell us it's not positive, and it's going to ask us for a positive value. So let's run it. Let's go to our command window. Oh. Hold on. Let's just do 9. It stops. We got to delete this because we don't need that. We'll put semicolons on here, and let's try it again. Okay, so enter a positive value. So again, if I enter 6, boom, it stops. But let me go back, and if it's going to be a negative value, so say -5. It says x is not positive, please enter positive value. So -4, and it keeps repeating. Okay, we're going to hit Control C because I don't like the formatting in that. So I'm going to add a space here. Why don't we do this and then say enter positive. Oh, we can't. Okay, we'll just do that for right now. Enter positive value, -3. X is not positive. Please enter positive value. So I'll put 5. Boom. I deleted it. Okay. Let's do this. Just to format. Positive value, so -3. X is not positive. Please enter a positive value. -8. Or sorry, -7, -9. Okay, it's not working. Finally, 2. Boom. It stops. So that's why we use while loops. Okay, so while it's less than or equal to 0. So it's going to keep, if it's negative, basically saying if it's 0 or negative, go into these commands and keep doing it until you get to a positive value. So above 0. Okay, cool. All right, the last example is going to be very similar to the for loop example for projectile motion. And I'm going to do this. Okay. So again, acceleration due to gravity is -9.81. We have theta, 75 degrees. Okay. Initial time, so t of 1 is 0. We're going to pick a time step of 0.1. Initial velocity is 35. Initial x, initial y is 0. Here's our loop indicator for the while loop. And this is going to be our criteria for the while loop. And I'm going to show you this. Okay. We're going to plot, and this is the access limits. All right. So what we're going to do is we're going to say while not done. Okay, and then I'll put my equations. Boom. So x of j, so j is currently 1. We haven't added that loop indicator. We haven't changed that. Equals x naught plus v naught times t of j times cosine of theta. Again, this is just a generic equation used to calculate position. Y of j equals y naught plus v naught times t of j times sine d of theta plus 1/2 ay t squared. All right. So let me just do this so you can understand. So j equals j plus 1, and then just put n for now. So in this case, let's just recap. Go back up here. We have constants. We have givens. Acceleration due to gravity. We're going to throw the ball at 75 degrees, which we can change. The initial time that we're doing is 0. We're going to have a time step of 0.1. And I'll show you that here in a second. Initial velocity, initial positions. We have our loop indicator, which starts at 1. And then in the loop, it's going to keep incrementing up. And then the done criteria is going to start at 0. But what we're going to do is we're going to stop the code if y of j is less than 0. And we're going to say done equals 1. So it's an if statement. So we put an if statement in the while loop. So it's going to calculate y here based on our j and our time, right? So at time of 0, plug it all in here. If y is less than 0, boom, it's going to stop the code because now done is now changed to 1, and it will break out of the code. Okay, so it's going to keep doing the code because done equals 0 until we change it to 1, and then it immediately breaks. Now the time, we're going to add that increment of delta t. Okay, so t of j plus 1. So the next time interval, actually we can change, yeah, let's put it here. No, that's fine. So we're changing time. So j is 1 initially, but j will be 2 in this case, and it's going to equal to t of j, which is currently 1. So that's going to be 0 from up here, because time of 1 or j of 1 is 0. Then it's going to add delta t, so 0.1. So this is how you change your time, which is used in these equations. So when j is 2, it's going to say j equals j plus 1. So that now is 2. It's going to go all the way back to the top, and it's going to have 2, 2, 2, 2, 2. Okay? And we've already calculated what t of 2 is going to be, which is 0.1. Okay? And let's just plot. And let's add this right here. And I'll just take that out for a second. So we're going to plot figure 1. We're going to plot x of j, y of j. So these are going to be 1 numbers each. We're going to make them pluses, marker size 20. We're going to hold on so we can see all of these plus signs build up as we plot this. And it's going to draw now, meaning it's going to update the graph. Okay, so let's go ahead and hit run. And go back up. Got to go all the way to the top here. Let's just comment these commands and format comment. Okay, then we don't have to run those. Okay, look at that. It was kind of fast. Let me put a delay in there. I think we can pause 1 second. Right here, pause 1. And I'll reiterate what's going on here. So the way that this is working is we're doing a while loop, and we're doing it while y is always positive, pretty much. Okay, so it's going to keep plotting points because y, because this is 10, this is 20, this is 30, 40, 50, 60, okay, meters. It's going to keep plotting this until basically y is less than 0 or negative, and it's going to stop. Okay, so this is running the code. And again, I put pause of 0.1 seconds so you can see what's happening here. Then I'll reiterate everything that we just did. So it's coming up. Boom, and then it stops. Okay. Now, if you notice, this last data point is negative Because if we go back to the original, how I showed you what a while loop is, it will calculate one more and then break out of the loop. Okay? Which is fine. It's okay. It's not a big deal. All right? So let's recap what I just did here, because there's a lot of information here. So let's go to the top. We established givens: acceleration due to gravity, the angle we're throwing the ball, the initial time, which this t of 1 indicates that time is going to be a matrix, and we're going to build that matrix. We have a time step, so we're going to increment every 0.1 second. We have our initial velocity, initial positions, x and y. We have our loop indicator because we're using a while loop, so you always you got to define your loop indicator. Sorry. This done equals 0 is our criteria for our while loop. We're creating a figure with an axes of 0 to 120 and 0 to 20. And then we have our while loop. And let me just go down a little bit. That's fine. So in this case, we're saying while not done. So this means that we establish done, this parameter equals 0. This is going to keep going through this loop until done is a different number other than 0. 1, 2, 3, doesn't matter. Once it says that, it's going to break out of the loop because we have right here this condition. If this y of j is less than 0, we're changing done to 1 and it breaks out of this while loop. Okay, so we're using an if statement in a while loop to break it out, to stop running the code. Otherwise, it'll just keep running and running and running. Okay. Up here, these are just equations to plot projectile motion, pretty much. You have x, which is position in the x, and y. And if you notice, inside a while loop or a for loop, you always have this parenthesis j or I or whatever. That means that we're building the matrix. J is going to start from 1, and it's going to go 2, 3, 4, 5, all the way up until we stop the code. Which line 87, that is how we're changing our loop indicator. We're adding 1 every time. In a while loop, you have to do that. In a for loop, you don't. It's already established. Okay, so again, we're building this x matrix and y matrix because it's on the left of the equal sign. On the right of the equal sign, wherever you have t, which is going to be a matrix, because we're building t as a matrix. Okay, it starts at 0 and it goes by 0.1 because that's our delta t. So it's 0.1, 0.2, 0.3, and so forth. You need to put the parenthesis j here because it's got to grab one single value. Okay, so it's grabbing one value. So if j is 1, then time is 0. But j is 2, it's going to grab 0.1 because time of 2 is 0.1. And then cosine theta. And theta is just a constant. That's just what we defined it as. Same thing with y. Here we have time here, but we also have time over here. Okay. And technically, we do not need these dots. I'll just take those out because we're in a loop. Because we're only, this number right here is one value. Okay. Again, this right here is our breakout point. So if y is less than 0, we change done to 1, and then this is no longer valid, and boom, it breaks out of the code. Down here, this time, we're saying that time of 2 or 3 or 4 is the previous time added to some increment. Here, we're just plotting the points, the individual points. And then here's our loop indicator, and then we're pausing. Now we can pause 0.1 second. And it's a little bit faster, right? And my surface might have froze. Oh. not responding. Nah. I shouldn't have moved it. Oh. Oh. Octave kind of froze here. Close. Let's see what happened. All right. Let's open it back up. Go back to the editor. Go all the way down here. And I'm just going to take it out. If you hit Control R, it comments. And this will be fast. Okay, boom, done. All right. And if we go to our command window, we type X, it's going to be one row with 70 columns. Okay. If we type T, okay, T goes to pretty much 6.9 or 7 seconds. You got Y, and that's, see how it's positive, but then one more is negative because it's checking. Remember, while loops will check. This is still positive. It does one more calculation and it checks this. If that's no longer positive, it breaks out. Now, if you did notice, X has 70, Y has 70, but time has 71. So that's just one thing you have to watch out, because in our code here, we calculate X and Y first. And then down here, the previous loop, it actually calculated another J because we added one here. All right. So it took about 6.9 seconds to get the ball to go from wherever we started with initial velocity to the ground. Okay, I hope this kind of helps understand while loops. Again, these are not easy. These are probably the hardest loops to learn. But make the code, run it, check it out. If you have questions, let me know. Thank you, and have a good day.